Hi, my name is Keith Ellenbogen. I'm an assistant professor of photography at SUNY, the Fashion Institute of Technology, and a visiting artist at MIT Sea Grant. I'm an underwater wildlife photographer and currently working on a National Marine Sanctuary Foundation Hollings Ocean Awareness Award to use the art of photography and microscopy to connect people to the extraordinary underwater world within Stellwagen Bank National Marine Sanctuary, from ocean giants like humpback whales and great white sharks to microscopic photosynthetic dinoflagellates like these three serratia that are in vast numbers, generate much of the oxygen we breathe, and form the base of the food chain. Within the United States, there are 15 national marine sanctuaries that are designated as special places that protect both the marine wildlife and their habitat. Stellwagen Bank National Marine Sanctuary is located just 25 nautical miles off the coast of Boston and just 2 nautical miles south of Gloucester or north of Cape Cod. To collect samples, we set sail on board MIT Sea Grant's boat and traveled to Stellwagen Bank Sanctuary. As part of this project, we were engaging students in all aspects of plankton collection and image gathering techniques. This gives students at MIT a unique hands-on experience in how art and science can enhance visual communication and storytelling. Our process is to conduct a plankton tow, collect a concentrated sample, bring the living plankton back to the lab, where I put them under a microscope, and apply my skills as a wildlife photographer, focusing on light, composition, color, rhythm, and movement to create an emotional connection to these microscopic creatures. Each slide is an opportunity to explore and discover. This exotic-looking creature is a radiolarian. Dinoflagellates are a large diverse group of single-celled algae that are of immense importance to the marine environment. In addition to photography, video can reveal the rapidly undulating flagella and the currents it creates. As part of my image making process, I like to use a combination of dark field, polarization, and image stacking techniques to illuminate the subject and to show the full focal range. The blurred tips of these dinoflagellates reveal a subtle movements that elicit a sense of motion within the overall composition. Even within the microscopic world, there are signs of pollution. This image shows 2 dinoflagellates intertwined with microplastics or microfibers. Additionally, I've also been experimenting with other photomicroscopy techniques at the intersection of art, science, and technology. For example, the red fluorescence within this image shows the distribution of chlorophyll within the cells, as well as a visual expression of ruby red. Or using a scanning electron microscope to create an extreme close-up view that reveals the intimate insight into its complex body, shape, and texture. But the image that I'm most proud of is this composition of 3 interconnected serratia that are currently on exhibit at the Koch Institute of Public Galleries, in which their microscopic size is exhibited exponentially larger than life, symbolizing the gigantic impact dinoflagellates have on our planet. This project is a collaboration that involves many people and organizations that I'm extremely grateful for all their support and encouragement. Additionally, I want to thank Dr. Tom Concy, who I work with at the lab at MIT Sea Grant, and who exemplifies a collaboration between art and science. And finally, I would like to thank the Koch Institute of Public Galleries for this opportunity. Thank you very much.